Okay, so I will get started. Thanks everyone for joining this week's C3 AI Digital Transformation Institute seminar series. A short introduction of the Institute. C3 AI Digital Transformation Institute supports research, especially the world's leading scientists, in coordinated and innovative effort to advance the digital transformation of businesses and government and society. And it especially attracts and gathers research that focus on groundbreaking tools in machine learning, computer science, and societal systems that transform our society and creates public good. I want to take a pause here to acknowledge the support we receive from our academic partners, the high performance computing support and industry partners. We have a very exciting seminar series this semester. It's on incentive, design, and learning for societal systems. And this is the list of speakers of all the upcoming talks and the schedule. You can find the speakers' bio, talk title, and abstracts on our website. We have had fantastic 5 talks in the past of this seminar series. If you have missed them, you can find the slides and their talk videos either on our website or on the YouTube channel. So we post their talk videos a few days after the talk, as soon as they become ready. To avoid missing our future event, please take your time to subscribe to our newsletter. Okay, so it is our great pleasure to welcome Dr. Nicole Immorlica to present her recent work on communicating with anecdotes. Dr. Nicole Immorlica's research lies broadly within the field of economics and computation. She uses tools and modeling concepts from both theoretical computer science and economics, and her research goal is to explain, predict, and shape behavioral patterns in various online and offline systems that includes markets and games. Her areas of specialty includes both social networks and mechanism design. Nicole received her PhD from MIT in 2005 and completed her postdoc at both Microsoft Research, Redmond, and also CWI in Amsterdam. And she has been an assistant professor at Northwestern University in Chicago, and she joined Microsoft Research Center in 2012, and she's currently based in Boston, MA. So the seminar, as always, we have 15 minutes presentation of the talk. Since this is in webinar mode, please submit your questions in the Q&A sessions, and we will try to ask as much as we can on your behalf at the end of the talk as time permits. So without further delay, I would like to give the floor to Nicole. So Nicole, you can unmute yourself and open the video and share your slides. Thank you, Nicole. Welcome.
Thanks for the introduction. I am Nicole Immorlica, and I will be talking to you today about communicating with anecdotes. So this is a paper, it's joint work with Nika Haqtalab at UC Berkeley, Brendan Lucier at Microsoft Research, Marcus Mobius at Microsoft Research, and Divya Mohan at Tel Aviv University. And it really, I think is a nice paper for this seminar series because it was really born out of interdisciplinary conversations. So very early on, the lab I work in at Microsoft has some communication specialists that study social media and how people communicate and why they communicate. And so I was talking to Nancy Boehm, who's one of the researchers in that category about communication, and she really was the inspiration for this project by talking to us about how people talk in facts or like speak in anecdotes. And so this is kind of like the history of this paper. So with that background, let me get into a little bit of motivation and description of our results. So the game that we're going to discuss in this paper is a communication game. So we have a sender, and the sender is going to talk to a receiver about the state of the world. You can think in your mind about examples like politicians who are going to talk to constituents about policy decisions, or newspapers that might want to talk to readers about current events. So, you know, this we had envisioned originally a nice rich model with two-way communication, but this is just sort of the first step of this research agenda. And we're going to have a sender who sends some communication to a receiver, like a politician sending a communication to her constituents. The state of the world is something that is like the policy decisions that the politician knows and wants to communicate to her constituents, or the current events that the newspaper researched and wants to tell the readers about. The key and like sort of features of this type of model are that there's some information asymmetry. So the sender in these examples naturally knows more about the state of the world than the receiver. And that's the source of the information asymmetry. There's also hard evidence. The politicians and newspapers, and this is sort of the insight of the communication specialist, that these senders will naturally get their messages by assembling examples and factual statements. So there's little sort of blatant lying in these kinds of communication scenarios. And then there's also some agency. And the agency here is that the receiver is going to decide how to act, and her choice is going to be influenced by her beliefs about the state of the world. And furthermore, her action will impact the sender. So just to be a little more precise, the information structure includes a signal about the payoff relevant state of the game. So this signal is going to be the facts and examples that are available to the sender. And the sender's strategic choice is going to be a communication scheme, which maps the information she has to what she decides to say to the receiver. The receiver, on the flip side, has an information structure which consists of her beliefs about the distribution of the signal and the state of the world. And then her strategic choice is the action, which maps the information that's been communicated into her into a payoff relevant action choice. And the fact that this action is payoff relevant for both the sender and receiver will be driving a lot of the results in the paper. The agents are going to pick their strategies in order to maximize their utility and expectation over the state and the signal. I'll make this mathematically precise in a few slides, but let me first here's some notation that just to give you a little bit more mathematical precision, and then I'll discuss some examples before I formally state the model. So the state of the world, we'll think of it as some point in a real number line, and the actions are going to impact, the action of the receiver is going to impact the utility of the sender and receiver by some function that relates their ideal point to the action that is taken. So the sender might want the action of the receiver to be, say, slightly left to the state of the world, whereas the receiver might want to take an action that's slightly to the right of the state of the world. So you can think of the sender as trying to pull society a little bit more left, and the receiver as being a little bit more conservative, a little bit more to the right than the sender, but both of them care and are impacted by the state of the world. Some examples for this. So in politics, you could imagine that you have a president and she has some research, some stories from constituents, and based on this research by her or her election committee or her staffers, she knows something about the state of the world. And then she's going to communicate about this using speechwriters to her constituents. And maybe, for example, this might be about the gender wage gap. And so she's going to research the gender wage gap, and then she's going to give speeches about the gender wage gap. And her constituents, being employers, are going to listen to this, form some beliefs about it, and then try to decide how much to pay their employees. And what's going on here is that, why might their preferences not be over the actions, over the payments to the employees? They might not be completely aligned because maybe the president values fairness over free markets more than the employer, and so has an incentive to convince employers to pay women more. And the employer, if they knew the gender wage gap exactly, might want to just not overpay for employees, and they know women have worse outside options, so they might just want to, make the offers that are consistent with the current gender wage gap. Another example here is journalism. So you have newspapers that want to communicate facts to the readers, and the signal that the newspaper has access here is based on their journalists' research into some current events, say COVID. And the communication scheme is then going to maybe be the editorial policy of the newspaper about what they publish, which subset of facts and that the journalists have uncovered do they choose to publish. The reader is then going to form beliefs about the state of the world. So if it's COVID, for example, they'll form beliefs about the danger of COVID, the effectiveness of wearing masks based on the stories they read in the news. And the action that they are going to take is the fraction of time that they spend wearing masks, let's say. So again, the preferences might not be completely aligned here. Maybe the newspaper values health over personal freedoms, like more than the readers. And so they want the readers to wear masks more often than the readers would if they knew exactly how effective masks were and how dangerous COVID was. So in both of, in this setup, those are sort of the motivating examples. And in this setup, I want to think about the communication that is sent by the sender to the receiver as being an anecdote. And so what is an anecdote? And I'll make a formal statement of an anecdote in the context of a mathematical model, but what I want you to have in your mind intuitively is that an anecdote is something immutable, which I can choose to include or exclude when I talk to you. So the signal then that the sender has is going to be a set of samples that are drawn from the state of the world. And these samples are going to be what we call the anecdotes. We also, I won't be able to get to this given the time constraints, but there's also a question of whether maybe the sender even knows exactly the state of the world, or maybe the sender only has some prior over the state of the world. But even if the sender knows exactly the state of the world, which we call the foresight setting, which you can model by including that in the signal, there still might be some incentives for the sender to communicate anecdotes that are potentially biased. Here's some examples from the motivations I presented to you. So in the political example, I was saying that the president might want to make speeches about the gender wage gap that convince people that it's high or low or whatever. And so this is a story, this is actually a snippet from a stump speech by Clinton. And you can see that this highlighting, by the way, is not mine. This highlighting is from the NPR article from which I drew this example. You can see that in her stump speech, she actually leverages anecdotes to communicate her message. So here she has a whole story about two people who are very similar, but one's male and one's female, and they don't get paid the same amount of money. And so this is what she communicated in her stump speech. Similarly, you can think about examples from journalism, like the New York Times published this page when the US deaths from COVID reached 100,000, which was May 24th, 2020. And so what they published was this fact that US deaths near 100,000. And, so they selected that as the anecdote that they would communicate. It's a fact. There were many other facts they could have picked, but this is the fact they picked to publish in their newspaper on that day. So what we want to understand about this sort of game where the sender has to pick a subset of facts to communicate to a receiver is what do we expect to be communicated and what sort of actions do we expect to be taken as a result? And the first observation, or the first modeling assumption that we're going to introduce is that the sender can communicate only a single anecdote. That will simplify our analysis quite a bit. And then we're going to ask about the properties of that single anecdote that gets communicated. We'll ask about the bias, and we'll see that the sender wants to use a biased anecdote in order to convince the receiver that the state is closer to her ideal point. And then we'll ask about the accuracy. And for that, we'll see that the sender, if we fix the bias that the sender is choosing, then the sender has an incentive to minimize the variance of the receiver's action, because she wants the receiver to, that the variance of the receiver's action will negatively impact her utility. Then we can also ask about which sender, so our results are going to have interesting implications for polarization and how much people listen to experts. So we can ask, which sender would a receiver prefer to listen to? So this is completely hypothetical. Our model in this sort of early stage of the research agenda has just a single sender and a single receiver. But you could ask, if there were two parallel worlds, which world would the receiver prefer to live in? And so the polarization result says that the sender prefers the world in which the receiver prefers the world in which the sender has similar ideal points, so similar preferences, because then the signal that the sender sends will have less bias. The anecdote that the sender communicates will have less bias, and so the receiver will have more accurate beliefs. And similarly, the receiver may prefer a sender fixing their preference misalignment, a sender with many anecdotes. So you can think about the number of anecdotes that a sender has access to as her expertise. And the receiver may prefer a sender with many anecdotes, because even though the anecdote that gets sent might be more biased, it'll have less variance. And so the receiver can more accurately debias it. So I'll get into those points a little bit later on. Let me discuss the solution concepts that we're going to use. So we have the sender, the agents are choosing strategies here. The sender is strategically selecting the communication scheme in order to induce the receiver to take certain actions. And there's two solution concepts we study. One is a Nash equilibrium, which you can think about as being a world without commitment. So the sender and receiver both simultaneously pick their strategies in a way that is a best response to one another. And that's what I'm going to focus on in this talk. We also in the paper study a Stackelberg setup, where the sender is going to commit to the communication scheme, and then the receiver gets to best respond to the commitment. And so that has slightly different implications, and I will refer you to the paper for the details of those. The results we'll see in these settings are, first, when communicating with anecdotes, there is an equilibrium in which the sender is going to send the, and I'm stating it as there is an equilibrium like this. I think it's interesting to maybe try and get some uniqueness results. We're working on that, conditions under which this equilibrium is unique, but there's a sense in which it feels focal. So the sender is going to send an anecdote that's close to some predetermined shift of the state of the world, or her posterior on the state of the world if she doesn't know it. And then the receiver is going to debias this anecdote by selecting an action that's trying to shift it back. And then the receiver is going to optimize her action given that implied posterior of the receiver about the state of the world. Then we can see from this result about describing, characterizing the equilibrium, we'll see that in this Nash setting, the equilibrium scheme is biased. And furthermore, the bias of this scheme grows as the difference in ideal points grows, which means that the receivers prefer senders that are closer to their, that have more similar preferences. And it also grows with the the bias grows with the number of anecdotes. As the sender has more examples to send, she'll pick more and more biased ones. And that introduces more variance. And then in the Stackelberg setting, which I'm not going to cover, the result says that the equilibrium scheme, Stackelberg equilibrium here, is unbiased and asymptotically sends an anecdote closest to the posterior. So it's really good for society if the sender can commit. And in the paper, we interpret commitment here as another sort of sender and receiver you can imagine is you yourself communicating as the sender, communicating to your future self. And your memory is, you have to decide, maybe subconsciously, what experiences to remember in order to help your future self understand how to act. And so you could imagine that your personality is sort of like a commitment to remembering certain anecdotes that will then influence how your future self acts. But anyway, that's sort of philosophical, and I won't get into that in the talk beyond this comment. So there's a bunch of related work, and this paper really lives in the econ literature. So I'm not sure how familiar you all are with it, but there's like two classic papers that are related to this. One is the cheap talk work of Crawford and Sobel, and this is talking about how signaling is more informative when preferences are more aligned. They study a very similar setup to what we do, and they use their main example in their paper is using the same utility function that I will use. But the difference is that in their model, at least like ex ante, there's nothing constraining what you can communicate. Whereas in our model, I'm really taking as fundamental this idea that we can only talk in facts, and we only have like a finite set of data that we can use to communicate with each other. Then there's also this classic literature, recent but classic literature on persuasion games or information design, and that's more related to the Stackelberg results in the paper, so I won't get into that. There's also a lot of literature on this kind of selection of facts that you want to communicate or voluntary disclosure. Most of them have what we would call full unraveling conditions, in which you don't want to hide information, because then the receiver will assume the worst about you if you try to hide information. And so you can then sort of question when that holds, and you could view our result as another sort of environment in which full unraveling fails. So those are the sort of related papers, and I'm not going to get into them in detail, but I would encourage you to look at especially these classic papers, and maybe also the full unraveling results from the selection literature if you're interested in this line of work. So let me now get into the precise mathematical model. So if you've zoned out from the introduction because you don't like motivations, time to wake up again. I'm going to now present some notation, and then I will characterize these best responses of the agents in this game. And then we'll use these best response characterizations to infer the equilibrium, like a sort of condition that characterizes the Nash equilibrium, and then we'll conclude. So again, this is a game with a sender and a receiver. We can think about the game as taking place on the real number line. The state of the world is some real number. I'm going to assume that it's drawn from a diffuse prior. That is, it's equally likely to be anywhere. This is obviously not completely precise, but it can be made mathematically formal. The sender and receiver each have ideal actions that is, each have an ideal action for the receiver. The receiver is the one taking that action in this game. And these ideal actions are defined as a shift from the state of the world. We will, throughout this talk, write the sender as being to the left and the receiver as being to the right of the state of the world. these shifts are common knowledge. So both the sender and the receiver know what the shift of the sender is, but they don't know the point itself. They just know like that my shift is ms from the state of the world as the sender. Then we also have a set of n anecdotes. The number of anecdotes n is, you can think of it as the expertise of the sender, and that is also common knowledge. And these anecdotes are drawn IID from a single peaked and symmetric prior that is parameterized by theta. So we don't actually need these strong conditions of single peakedness and symmetric. We can relax this, but for the purpose of this talk, I think it's easier to imagine that this is the world we live in. So for example, from now on, you could just think that the anecdotes are drawn from a Gaussian with mean theta, which is the state of the world, and variance 1. Again, to emphasize, the ideal shifts are common knowledge, so the strategies can condition on them. And the number of anecdotes and class of priors from which they're drawn are also common knowledge. The sender is the only one who knows the anecdotes. That's fundamental to the model. And for the purpose of this talk, we will also assume that the sender knows the state of the world, but in the paper we study what happens if the sender just has a posterior belief about the state of the world. So the sender is going to choose a communication scheme. This is her strategy. And a communication scheme is a mapping from one of the revealed anecdotes, or from the set of revealed anecdotes to the one that she chooses to communicate. The receiver, her strategy is to select an action rule. So an action rule is going to take that anecdote that was communicated and map it into an action that she's going to take. So these are the strategies, and the timing that I want you to have in mind is that the sender selects the communication scheme and the receiver selects the action rule simultaneously. Then the anecdotes are revealed, and then everything else happens mechanically. The anecdotes are revealed, the chosen anecdote is communicated, and the action is taken. You can also, it might be more natural, and this also works, to first assume that first the anecdotes are revealed, then the sender picks one, and then so you can also have that timing in mind. I just find this timing a little bit easier to conceptualize. What are the utilities? The sender, I'm going to use squared loss. And so the sender's utility is the squared loss between her ideal points and the action that the receiver took. And so she wants to minimize this squared loss. The receiver similarly has a squared loss utility between the action that she picked and her ideal points. And then the equilibrium is exactly what you expect an equilibrium to be. It says that the strategies, the communication scheme of the sender and the action rule of the receiver are an equilibrium if the receiver is best responding to the sender's communication scheme. So, the receiver will understand what the selection rule is for what anecdote she receives, and she'll form posterior beliefs about the state of the world and try to minimize her squared loss with respect to those beliefs. And the sender's also is best responding to the receiver's action rule. And again, there's some Stackelberg results in the paper that we will skip here. So now let me go through the characterization. So this is the model. I guess this is a good chance to ask if you have questions about the model.
I have a question. So is the sender allowed to lie, or they have to only pick one of the messages that they saw?
That's great. Yeah. So the sender, it's very fundamental to this paper that the sender has to take a fact. There's no fake news. The sender has to send a fact. But the thing is, like, the sender can select which fact to send. And I find this interesting because, like, I don't know the degree to which there's blatantly fake news in the world versus, Breitbart just decided to tell me only half the story, right? So this is really what I'm trying to get at.
The other question is in the objective function, you had theta plus a shift.
Yes.
For example, in some of the application examples that you gave for equal pay, for example, it might be the goal might be a independent of theta, right? I mean, there might be a state of the world that could be, let's say there's a bias in the pay today, but you might want to get to equal pay, in which case what you're trying to achieve is actually a single point, not compared to today's baseline. So yeah,
that's a very fair point. When we first wrote this paper, we wrote it with that model where I was trying to just achieve a specific real number, but I think that for different situations, maybe I should change the equal pay example, but like different assumptions apply to different situations about that. And the shifted state of the world is kind of more convenient for the Stackelberg setting, because what we'll see is that I'm going to define a class of strategies that we call translation invariant. And translation invariance, I think, is arguably very sensible in worlds where numbers don't have any real meaning. Everything is anyway relative to everything else. Now, for the Nash equilibrium results, translation invariance is without loss. Like the equilibrium isn't still an equilibrium even when I allow a broader class of all possible strategies. But for Stackelberg, it is a meaningful assumption.
Thank you.
All right, so let me present the characterization results. This is just a reminder of the informal statement of the theorem that I'm going to try and tell you about, which is that there's equilibrium has this sort of form that the sender is picking sort of a shift of the state of the world and trying to find an anecdote that's representative of that shift, and the receiver is then debiasing it and picking an action that's equal to the debiasing. So in order to get there, I will first define these translations that I was just talking about. We are going to say that an action rule is a translation. So this is the receiver now. Her action rule is a translation if for all X, all anecdotes that she receives, if I shift that anecdote by delta, then her response is to shift her action by delta. Okay. And note, first of all, that if an anecdote is a translation, then there is some constant shift sigma such that the action rule, the action that I take in response to an anecdote X is equal to X plus sigma for all X. And hence we can interpret this sigma as some sort of debiasing. Maybe it's a little bit more than debiasing because I also want to pull it towards my ideal point as the receiver. But you can think about sigma as like a sort of debiasing attempt by the receiver. So that's a translation of an action rule, or that's like a class of action rules. Now let's talk about the sender strategy and a class of sender strategies. That is a class of communication schemes that also has this kind of translation invariant feeling. So we'll say that a communication scheme is translation invariant if for all states of the world theta, for all sets of anecdotes X that the receiver might receive, and for all possible shifts delta, when I shift both the state of the world by delta and all the anecdotes by delta, then what I choose to send, the communication scheme is picking an anecdote to send, right? So the anecdote that gets sent in this world where everything is shifted by delta is equal to the anecdote that was sent in the unshifted world plus delta. Okay, so like if I add 1 to all the numbers, then what I send is the anecdote that I would have sent before, but plus 1. So this is translation invariance. And I tried to sort of give I think, first of all, as I discussed in the conversation earlier, that this is a natural class of strategies to consider, given that the prior over the state of the world is completely diffuse, and the shifts are all relative to the state of the world, and hence the number 0 has no real meaning in this game. You can also think about this as being sort of a natural class of schemes, in that it captures this idea that agents are contemplating the bias of information. So let me first show you some examples just to make sure we've understood of translation invariant communication schemes. The minimum anecdote is translation invariant. If I shift everything to the right, the minimum is shifted to the right by that same amount. The anecdote closest to the state, that's not a very good picture in my slide. That's not the anecdote closest to the state, but the anecdote closest to the state is a translation invariant. The anecdote closest to a shift of the state is also translation invariant. And this is a very interesting one. This will be actually the type of communication scheme that shows up in our equilibria. And we're going to call this kind of communication scheme a targeting scheme. So this is saying that the sender is going to take theta, the state of the world, shift it by tau, and then find the anecdote that's closest to tau. Another thing that's going to be very important is the bias of what gets sent. I mean, first of all, this is just, I think, an interesting quantity to study, an interesting property of the equilibria, but also it'll help us characterize the equilibrium. So let's define the bias of a communication scheme to be the expected anecdote given theta equals 0, or equivalently, the expectation of the communicated anecdote minus the state of the world. Then let's think about this targeting scheme that I told you is going to be of particular interest to us. This targeting scheme is sending an anecdote that's closest to some shift of the state of the world. What is the bias of this targeting scheme going to be? Well, the distribution that we're imagining is, like, say, Gaussian, is denser closer to the state of the world. And so the distribution has more anecdotes closer to the state of the world. And so the anecdote that's closest to this shift is more likely to be to the right of the target than to the left of the target. And hence the bias is going to be somewhere to the right of the target. And so we should expect that the bias is greater than tau in this picture. And another thing that's going to be a particular interest is this gap between the offset, tau, and the bias of the targeting scheme, beta of pi. Okay, so now let's think about, now that we have these foundations of the class of strategies for sender and receiver, as well as this notion of bias, we are ready to describe a receiver's best response. And what we can prove is that the best response of a receiver to a translation invariant communication scheme is going to be a translation with some shift. And that shift is going to be the kind of preference of the receiver plus the bias, or minus the bias in this case. So how do we prove this? Is super simple. I can do it in 3 lines. By definition of bias, the communicated anecdote minus the bias of the communication scheme is an unbiased estimator of the state of the world. So that's the debiasing step. And so the utility of the sender is going to be, remember, we're using squared loss. So we can sub in this unbiased estimator for theta. And then we get the thing on the right of this equality, and we see that in order to maximize this, or minimize the squared loss, maximize the utility, what we should do is pick an action rule that's equal to the debiasing plus MR, which is the target sort of shift of the receiver's action. Okay, so that's great. Now we've seen that if the sender is using a translation invariant communication scheme, the receiver is going to use a translation, and we even know what that translation is. Here's what's happening graphically. If you're more of a pictures person, the sender is picking, say, this anecdote that I've labeled on the slide with X. The receiver observes the anecdote that is sent. They know the bias of the communication scheme, and so they shift the anecdote by that bias to get their posterior belief about the state of the world. That's an unbiased estimator of theta. And then they shift that unbiased estimator to the right by their desired ideal point shift, right? Ideal shift. Okay. Now let's see what the sender is doing. So we know the receiver's best response. Let's look at the sender's best response. Let's first suppose that the receiver is using this class of strategies, these translations. Now let's suppose that the translation that the receiver is using has some shift sigma. Then the best response of the sender is going to be translation invariant, is the claim. And so if the proof for that is going to be that, let's imagine that the sender is using some communication scheme pi. Then since the receivers, we know the receiver's action rule is a translation with shift sigma, we know what the receiver's action is. It's going to be the communicated anecdote plus sigma. And so we can look at the sender's utility and we can just substitute in what the receiver's action is going to be. And what we see is that then the sender, this utility is going to be maximized pointwise by selecting pi equal to theta plus ms minus sigma, right? But the tricky thing here is that I can't say an arbitrary thing. So we discussed earlier how I can't lie. It's not just that I can't lie, it's that I can't communicate arbitrary things. I can only communicate facts. And so I can't say this, even though I want to as the sender. And again, pictorially, I've drawn what the sender wants to send. The sender can't say that. But what it can do is to return the anecdote that's closest to what it wants to say, that's most representative of what it would want to tell me. And this is exactly the definition of these targeting schemes with offset equal to, in this case, ms minus sigma. Okay, so what we've seen is that the best response of a sender to a receiver that's got an action rule that's a translation is to choose a translation invariant scheme with a particular, in fact, a targeting scheme with a particular offset. One thing to note is that these best responses are best responses among, like, I didn't restrict the response class of the person who's taking the best response, right? So among all possible, in this example, in this lemma, among all possible communication schemes I could select as a sender, I have a best response that is of this form, a targeting scheme with an offset. And that means that the equilibrium that I will show you in the next section of the talk is an equilibrium even in the broader class of all possible strategies for sender and receiver. So let me first take a slight detour to kind of give you some intuition about what's driving the sender's choice of bias in this signaling scheme, right? So we've decided it's a targeting scheme. We've figured out what the offset is for the sender's targeting scheme, and that implies what the bias is. But like, so you could alternatively think about the sender as picking the bias. And what is driving this bias, the choice of bias? How biased does a sender want to be? I think there's several sort of components that we'll try to uncover mathematically. One component that's driving the choice of bias is that I can't send arbitrary signals. I have to send an anecdote, right? So that's already forcing me to be biased, even if I'm completely aligned with the receiver. Well, I guess it's not forcing me to be biased, but like, even if I'm completely aligned with the receiver, I can't tell them the state of the world, right? So ex post, I'm going to send something that's not quite right, not quite accurate. There's also a fundamental gap that's due to like between the preferences of the sender and receiver. And so that's going to force some bias. And then there's a potential mismatch between the true bias of the signaling scheme and the perceived bias. Of course, in equilibrium, there's mismatch will be 0, but the fact that there's this potential mismatch is, this is sort of like a equilibrium condition that is pushing against the unraveling, or like actually pushing towards an unraveling condition. So let's see what these are mathematically. We've written down the sender's utility, and we can, with some mathematical manipulation, rewrite this as the following. The first equality is using the fact that the action is a translation. This second equality is then saying, well, we know what that translation is. We know what that sigma is. We calculated it in the receiver's best response lemma. And then this third equality is simple mathematical manipulation, and it gives us a way to rewrite the sender's utility in terms of the beliefs. This beta of pi of r is the belief of the sender about the bias of the the belief of the receiver about the bias of the sender's signaling scheme. And so when we can rewrite the sender's utility, and now we can interpret each term of this sender's utility, or I guess I rewrote it as cost because I didn't want to write the minus sign, as the first term is really the signaling cost. This is where the sender can't send an arbitrary signal. So this pi of s, she can't pick pi of s to be exactly equal to theta. And so that is causing some loss to her. And then there's this component that's the loss due to the fact that we just fundamentally disagree about what's the right action to take. And then this second term can also be interpreted as the persuasion temptation. And in order to see that, imagine that, say, beta is fixed, beta of pi of r is fixed, so the bias of perceived by the receiver is fixed. Then the sender is going to try and shift the bias of her scheme a bit more, to be a bit more biased, in fact, by this MR minus MS term, right? And then if we imagine, so now we can look at how this unravels, right? Now, if we imagine that the beta, we started with the bias of the receiver, that the receiver sees as fixed, then the sender wants to become more biased. Now let's fix what the sender is doing, and then the receiver is going to perceive even more bias. And so this is sort of pushing towards a complete unraveling where we get a fully like super biased world. But the thing that's driving against that is this first term, which is the fact that as we get more and more biased, the signaling cost goes up because our communication has more variance in it. Okay, so that's kind of the best characterization of best responses. And you can imagine that out of this will very easily fall the Nash equilibrium. We have this informal theorem statement that you've seen before about the Nash equilibrium shows us that the bias of the scheme is growing as we become more different from each other and as we get more experts in the world. And so to see that, let's look at the bias of the expected anecdote in some targeting scheme. And note that there's this gap between the offset and the bias, and that this grows as the target diverges from the state, right? So when my target is 0, then I'm going to have a bias that's 0, just by definition. And then as my target shifts to the left, the bias also shifts to the left, but more slowly than the target shifts to the left. And hence this gap, the difference between the blue arrow and the yellow star, grows as the target goes more and more left. And the rate at which this gap grows is a function of the number of anecdotes. So then with these observations and using the lemmas from the previous slides, we can show that there's a Nash equilibrium, like a particular strategy profile of a targeting scheme and an action rule that is a translation, is a Nash equilibrium if and only if the gap that I showed you on the last slide, that is the difference between the target, that blue arrow, and the bias, is equal to the preference misalignment. So you can think about the preference misalignment as being some fundamental of the model, and the difference between, the sender is going to pick a target such that it reaches this like, constant on the right-hand side. And they can do that because if the target is 0, it's 0. And as they pull more left, the target grows. So that's this characterization, this formula follows directly from the best response lemmas. And the existence follows from that kind of argument that I just sketched. But instead of getting into so I think it's pretty straightforward, and you could all complete this proof from this sketch here. Instead of doing that, what I'd like to end with is a little bit of a discussion of some comparative statics that are implied by this characterization result. So we have this idea that the gap must equal the preference misalignment. The first observation is that if we fix the number of anecdotes, as we saw, the required offset, as you move more left, the gap gets bigger. So the required offset is going to grow with the preference misalignment. So if our preference misalignment is somewhat small, I don't need to go too far to get to my required offset. But if it's larger, I need to go much farther out in the distribution to get my required offset. The other observation is that the preference misalignment, like if I fix that preference misalignment, if I fix the right-hand side, but let the number of anecdotes change, so I find senders that are more or less expert than each other, then again, the required offset grows with the number of anecdotes. So if there's very few anecdotes in the world, I don't need to go too far out to get to my required offset, because there's the anecdotes I find are anyway already going to be far from my target because there's not very many of them in the world. But if I have a ton of anecdotes, then I might need to go pretty far out in my distribution to get to the required offset as the number of anecdotes grows. And so this has some interesting implications. First thing to notice is that extreme anecdotes are more noisy. There's more variance out in the tail of the distribution. And so this induces signaling loss. And so for equal experience levels, so if there's two senders with the same number of anecdotes, the receiver prefers to communicate to a sender with more similar preferences. That is a sort of polarization result, right? Like we like to talk to people who are similar to us. And this is not saying that's because we have any sort of, bias about, or like, sort of hatred of people that are different, but simply because we get more information from them. And the second point is that if there's different experience levels, so I have some sender who's got many anecdotes and another sender who has few, then the receiver may prefer to communicate to the sender that has few anecdotes, that is the novice, if she has sufficiently more similar preferences. And an example that shows that is, you could imagine there's a sender which is an expert and has many anecdotes, but has a very different preference than mine. Another sender that's a novice that has few anecdotes, but the same preference as mine. Now, if we're in this Gaussian distribution world, then, no matter what world we're in, the sender one, as this preference misalignment is sufficiently large, is going to send the min or max anecdote. And for Gaussians, that min or max anecdote has vanishing variance. So I'm happy to talk to the expert, even though they're very misaligned. But for Laplace, or very heavy-tailed distributions, the min and max signal might have constant variance, and hence, if the novice has enough anecdotes, I could prefer to talk to the novice, even though they have very few of them. And so this is like another sort of polarization result, but also I think interesting because it's saying that we might we might seek out non-experts to learn about the world. And so with that, I will conclude. I think first I showed you a model of communicating with anecdotes, and I think that this is an interesting sort of starting point, because this idea that we communicate in facts, but the fakeness of news, if you like, doesn't come from lies or even from framing of facts, but rather from selection of facts. And how does that impact our world? And what we saw is, first of all, it results in information loss fundamentally, because we can't communicate beliefs. We can only communicate facts, and facts are fundamentally noisy. The information's loss is less so if the sender can commit. I didn't cover these results in this talk, but you can look at those in the paper. So if the New York Times could commit to always, sending to choosing their communication scheme before you choose your action role, then they could commit to sending the most representative stories as opposed to biased left stories, I guess. And so with commitment, as I just said, the sender picks the most representative anecdote. But without commitment, and this is what we saw today, the sender is going to pick biased anecdotes. And if we fix the number of anecdotes, this bias grows with differences in the preferences. And furthermore, if we fix the preference misalignment, then the bias of the anecdote that's sent grows as the number of anecdotes grows. And for some priors, this implies that the receivers prefer to communicate with less informed senders that are more aligned with their own preferences. And so this is, what we've done thus far in this paper, but I think there is a very interesting kind of, research agenda here about taking this single sender receiver game and looking into a bigger social network setting and asking things about how do social networks form, like that is, if we have everybody's maybe a receiver or a sender at each instant in the world, and how do they pick who to listen to or who to talk to, and how that will then, the network will then pass anecdotes around along its edges. And so how do these anecdotes flow through the network, and how do the beliefs and actions in society evolve as a result? So with that, I will conclude my talk and happy to take any questions.
Okay, thank you, Nicole. So we are going to open the question to the audience first. People in the audience, if you have questions, please submit your question in Q&A. And for the panelists, please just unmute yourself and ask question directly.
I guess I'll start off with a question. So, MR and MS are common knowledge. Is that
yes?
Right. This model, right? Yeah. So I guess one question is, what if we have to learn those?
Yeah. So this completely breaks even, like, as you saw, my translation rule is going to depend on the both the translation of the sender and the receiver depends on the MS and MR. Right. I
guess one could look at a Bayesian version of the problem where maybe if you have MS and MR have some distributions or something like that.
I was going to say that I think if the receiver is drawn from a distribution, then the sender will still just be like taking the, so if the belief of the sender over MR is common knowledge, I think everything will go through where the sender is just going to use the expected MR. Okay. I'm less sure what happens if the sender's preferences are not known.
But it sounds like that's an interesting extension, especially in the network context. If you don't know what everybody's preferences are, then I guess one will have to learn that somehow as part of your strategy. So that might be an interesting question, along with the open problem that you mentioned about how using this to say something about networks.
Yeah. Also, the MS and MR, I think maybe it can be estimated from some of these public surveys. For example, like people ask like CNN news article readers how their opinions about the topic versus some other news media to get some estimate of MS and MR. But yeah, I guess the receiver's preference is probably easier to be learned from these surveys, while the sender's agenda could be more secretive and only known by the sender.
I mean, I feel like we all have a sense that the New York Times is left of center and the
Yeah.
Washington Post is right.
Yeah, kind of.
So,
Yeah.
I guess, you know, to why do we know that? I think it's because they've existed for a long time. So if you imagine that the sender is somebody I've never seen before, sure, I'll need to learn their preference. And maybe I learn it over time through a repeated game where I observe my utility. So I now like know how biased they were today. And now we can continue and we can study. This could be a very interesting repeated game to study. In fact, like maybe the fact that the sender is basically impacting the future utility of itself through its actions today will help push it to be less biased. But in a world where like the New York Times has existed a long time before I was born, then I kind of feel like it's fair to think of it as rather fixed in its bias.
Yeah, I see.
And I can observe it and learn it by listening to the past.
Yes, another interesting question is whether which solution concept is more reasonable for this setting. It's a Nash or Stackelberg. I guess if it is a New York Times versus a reader, I guess maybe a Stackelberg model might be more appropriate, perhaps. I guess they have a sort of a first move advantage. I mean, everybody reads their opinions, and yeah, it's interesting. Yeah, it's unclear which is a better solution concept in this case.
Yeah, so we did like, I mean, I didn't really go into those results, but we did sort of select these two examples to have that one be the example of Stackelberg and the politician be the example of Nash.
Okay.
Because in a sense, like the politician is a bit more short-lived, right? Like,
right.
At least in the US, at least currently.
Also, I have a question about, so in this kind of persuasion setting, the ability of the sender is pretty much depends on how well informed the sender is, right? So in this case, this is like the could be the side information that the sender receives, like whether or not the sender observed the state or not, and also the number of anecdotes. So yeah, I wonder, like, how are they like both make sender more powerful, or like they're actually not totally aligned?
The number of anecdotes is very much impacts what's sent and the utilities that are received as a result. And so I think one very interesting question is what happens if the sender can, say, through some cost, acquire more anecdotes? Like how much research should you do before you talk to me?
I see. Okay.
That's some direction that we've contemplated. The state of the, like having the sender know the state of the world, I kind of think of it as a convenience, mathematical convenience. I think but you could still, yeah, I mean.
So like, for example, researching in getting complete information of the state versus researching to get more anecdotes, like it's like two directions.
Yeah, one is you talk to more people to get more examples that you could communicate, and the other is like, you know, you're a climatologist and you do a lot of research to create more accurate models, and then you refine your beliefs about climate change. That's true. There are two different directions. I agree.
Thank you. So we are 5 minutes over the hour. No. So thank you, Nicole, and thanks for a fantastic talk, and thanks for all the audience and the panelists. Thanks for everyone who showed up today. Yeah.
Thank you very much.
Okay. Thank you. Thank you, Nicole.
Thanks.